Okay, here is an example of a linear differential equation. So notice that, strictly speaking, in order to make it into the default form, we should probably, let me rewrite it as dy dt. We should divide by t cubed, so 3 over t y equals cosine t over t cubed. Strictly speaking, but I don't want to do that because I want to demonstrate something. So notice something special about this. So notice that if you look at coefficients at dy dt and at the coefficient at y, then the derivative of t cubed is precisely 3t squared. And I hope that you recognize the pattern, because this is the pattern of the product rule. Because here the left-hand side of our differential equation is precisely the derivative of t cubed times y. Well, indeed. So if you don't believe me, let's try to verify it. If you want to differentiate the product t cubed times y by the product rule, then you'll get t cubed times y prime plus the derivative of t cubed is 3t squared times y. Correct? That's exactly the left-hand side of our differential equation. Alright, so, and it is supposed to be equal to cosine t. Alright, so let me write it again. So, t cubed y product derivative is cosine t. But it tells us that, so imagine that instead of y being the unknown, the whole product, t cubed times y, is the unknown. So this expression tells us that the derivative of this unknown function is cosine t, which means that the original function, the unknown function itself, which is now t cubed times y, is the integral of cosine t, which is sine t plus constant. And that's basically it. So now we just need to solve for y by dividing the whole thing by t cubed. So if this is t cubed times y, then y itself is going to be equal to sine t plus constant divided by t cubed. That's the answer. And notice that here we don't have any ambiguity because we reduced our problem to just integration. It means that here we are guaranteed to have produced all possible solutions. Notice one more little thing is that strictly speaking t is not allowed to be 0 here because we are dividing by t, but this is alright because the original differential equation is not written in the form where the left hand side is dy dt, and if we are to write it into this form, then we would get this, and here there is division by t, which means that already from this expression it is clear that t is not allowed to be 0, right? So maybe we should mention that t here is not allowed to be 0.